Hello grade 7s, welcome to today's natural science video lesson. I hope you're doing well. Today we're going to be covering renewable sources of energy, and please excuse the appearance. I haven't gone for any haircuts or anything. Right now it's more about survival than fashion. So this section is on page 128, and I'm going to go through all the types of renewable energy sources. And we're going to then go through the activity on page 130, topic 9, revision. So if you remember back to our previous definitions, the word renewable means that it's not used up. It's never exhausted. So this is in contrast to our non-renewable sources of energy like the fossil fuels and uranium. And these are all minerals. So they're mined at the ground, out of the ground at a very high rate, faster than the earth can replenish them, and that is why they are non-renewable. So the first renewable energy source we'll look at is hydropower. So hydro relates to water. Okay, so you could also think of this as water power. Okay, and what happens is that we have a dam like this, okay, and a dam is built in a river. It impedes the flow of the river, and the water level builds up here, and on the other side of the dam the water level is much lower. Okay, so what would happen now is that they'd open a little chute at the top of the dam and the water would fall. So it makes like an artificial waterfall. So in the way of this flow of water that goes like this from top to bottom, in the way of that waterfall they'll have a generator. So here are the blades of a generator, and it will make this generator spin. Okay, so it's similar to when the wind blows, a windmill spins. Here, when the water flows, the generator spins. And whenever we have a generator spinning, it produces electricity. So you could say something like waterfall spins blades of generator, and this leads to making electricity. Okay, in the textbook it tells us that this type of renewable energy is very popular in countries where there are large rivers. So you can build dams by these rivers and catch quite a bit of power. So next up we have wave and tidal power. So this operates in much the same way as hydropower. The tide moves back and forth twice a day, and the waves move back and forth continuously during the day. So you can build a turbine, the generator underwater, and the motion of the waves moving back and forth will spin the blades of this turbine and generate electricity. Next, we're going to talk about wind power. If you look at the picture in the textbook, we have like these giant fans which stand upright, and the blades spin when the wind blows, and the spinning of the blades in the generator is what generates the electricity. So let's just talk a little bit about these wind generators. So they look something like this, and the blades are spaced equidistant in this triangle shape. So equidistant would mean that each of these angles is 120 degrees, equal sizes, and when we add them up, we've got 120 plus 120 plus 120 gives us 360 degrees. So the full pi, the full circle. So these wind turbines are generally very, very large. If we imagine the fan spinning in a circle like this, then the diameter of this circle for the very large turbines can be up to 120 meters. So that's gigantic. That's like the size of a football field. And my question to you is, why do you think they build these turbines so big? Wouldn't it be better if you had lots of little turbines arranged and they could all blow simultaneously when the wind blows? Why do you have to build such a big one? Well, one of the reasons is efficiency. When you have lots of little turbines, you've got lots of units, each with their own set of moving parts. Whereas if you build one big turbine, you've got one set of moving parts. Another factor is efficiency in harvesting the wind power. If you've got a big fan like this, it can harvest from that entire area. So if you've got lots of little fans, they can only blow, sometimes they'll blow, sometimes not, depending on the air currents at the specific points. But with this, the air currents at any one of these points can influence the spin of the generator. So lastly, we need to mention that these wind generators are generally not built in isolation. There are farms of them. And you will see in the picture, in the textbook, there are rows upon rows of them. Also, these wind turbines are built in areas where there's a consistent wind flow. So for example, by the coast. So during the day, the land is hot and the sea is cold. So the wind will blow outwards towards the sea. And during the night, the sea is warm and the land is cold. So the air flows inland. So day and night, there's a constant flow of wind to power these things. So next up, we're going to talk about solar power. Solar power is energy from the sun. We've already seen an example of this when we looked at plants. We said that plants, green plants, get their energy from the sun, and they use this energy to help convert nutrients into food. In man-made applications, we have solar power used in two different applications. We have the photoelectric solar power, and photoelectric would be the solar panels. You might have seen them before, arranged on roofs. In some instances, they'll arrange rows and rows of them in a desert. The solar panels, and they capture the radiant energy from the sun. Okay, so radiant energy is like the light energy. The heat energy is captured in a different application. Okay, so make note, radiant energy, light energy, and that's also the same energy that plants are capturing. Okay, the other application for heat is concentrated solar power, or for short, CSP. And this is capturing the thermal energy. Okay, how it works is that it takes a whole bunch of sunlight, the rays of the sunlight, and it focuses it to a single central point. Okay, and concentrating all these beams of sunlight generates a huge amount of thermal energy. So I just want to draw something for you to try and explain this. So we could have this curve. It's like a satellite dish. And we know that in the middle of the satellite dish we have an antenna, and this is a special kind of curve. It works in such a way that when the signals bounce in from outside, they are all reflected to this central point, the antenna. Okay, so all the signals bounce and are concentrated there. So this type of shape, it's a special curve. It's not a semicircle. It's called a parabola. And similarly to satellite dishes, they have arranged parabolas like this to capture sunlight. and it concentrates all the sunlight to a central point. If they don't have parabolas like this, they might have a tower built in the middle of the field, and they'll have a whole circle of panels around it, and it all reflects the sunlight to this focal point. So you'll see a picture of that in the textbook. So next up, we're going to talk about power storage. So a few of the applications that we've looked at, particularly with solar power and wind power, are not reliable. The wind doesn't always blow and the sun doesn't always shine. So we need a form of storage, okay? We need to store this energy, and when we don't have our power source, this storage will balance things out. So the way this energy is stored, as in the textbook, it's called molten salts. So storage, molten salt. Okay, so molten salt is, as the name implies, it means salt that has been melted. So when the salt is melted, it holds onto that thermal energy, and that can be used at a later date. So the last form of renewable energy we're going to look at is biofuel. So biofuel comes from the dead remains of plants and animals. We said earlier that plants capture the energy from the sunlight, and they convert that energy into, use that energy to convert nutrients into food. Food is another kind of energy. Animals will eat the plants, and the energy will be transferred to them, and essentially the sunlight powers an entire food chain. Now, when these animals die, they are in turn broken down by the decomposers. So the bacteria and the fungi. Remember, these are two of the living kingdoms out of the 5 living kingdoms. So this process is called biodegrading. So when the biofuels biodegrade, in other words, when they rot or decompose, then generally a gas called methane is produced. Okay, so methane is one of the gases that were found in the previous section on non-renewable energy sources. Methane is one of the gases when you mine oil. So when the dead plants and animals biodegrade, methane is produced, and this methane can be burnt so it's flammable, and you can generate thermal energy from this. And that is the main application for biofuels. There are some other applications like biodiesel, or sometimes this dead matter can be burnt, but this is the main one. So you won't see it in the textbook, just make a note of it. So that concludes today's video lesson. I hope you were able to suss out why all of these energy sources were renewable. Mainly it's because they come from natural sources. So the wind, the sun, the water, and the living organisms are all renewable. They're all replenished. So thanks for watching, guys. I hope you all understood. And the homework for this section is the revision exercise at the end of the section. I'll put the description in the link.